All right, guys. So some people have been asking about a couple of different questions, and specifically what I wanted to address right now was the condensed structural formula. Let me know if the video quality or the sound quality is off, and I'll try to fix that and get it a little bit better. But for right now, let's try to go with what we got. All right, so let's start off by looking at some patterns in uh, condensed structural formulas. I'm going to go down the line. If you see something like this, CH3, let me write it a little bigger. Then what can that possibly mean? How can that be in a structural formula? Well, you know, carbon's going to be 4-valent. It's going to have 4 bonds, 8 lone pairs. So what could possibly have a CH3? Well, that means that it has to look like this. All right. Same thing with a CH2. If you see a CH2 in a structural formula, what does that mean? Well, that means that carbon must be connected to 2 other carbons, because how else could it be CH2? All right, and then finally, let's take a look at CH. If you've got a CH, what does that mean? Well, that means you've got a carbon connected to 1 hydrogen. And how does that happen? Well, the only way that that can happen is if it's connected to 3 other carbons. I guess there could be the possibility of just having a C, which would mean that it would be connected to 4 other carbons. And I guess that situation is possible as well. Maybe as an example would be CH3 4C. So that's a condensed structural formula that indicates exactly what I drew up here, that you've got a carbon right there connected to 4 CH3 groups, so that it looks like that. All right, so let's take a look at a particular problem that somebody was working on. I'm going to try to find it here. Give me a second as I go through my email. I think here's what it looked like. It was parentheses CH3 CH2 2 CH CH2 O CH3. So let's try to decipher this particular structure. So look at some of those patterns that we saw before. Look, there's a CH, there's a CH2, here's a CH3, and here's something in parentheses. There's 2 of them, whatever they are. And so you can attack these problems any way that you feel comfortable with, but I'm going to start right there, because I think that is a telling symbol, right? Remember that we said that means there's a carbon and it's connected to a hydrogen. I also said that it means that it has to be connected to 3 other carbons. Well, where are the 3 carbons? There's one of them right there. It's right next to it, CH2. Then look back here in parentheses. This kind of gives you the rest of the idea. It's connected to 2 of the identical groups. And the identical groups that it's connected to are what's inside the parentheses, a CH2, CH3. Now, going back over here on this side, we've already got this CH2, and so next is an O and a CH3. So at the end of the day, this structure is where that's that carbon. There's that oxygen. There's that CH3. Now, I shouldn't have really shown that carbon. It would have all been connected like this. So that's the line structure, minus that business right there. So I hope that helps.